Hey y'all, today is March 16th and I am doing a little mini lesson on simple probability. So grab a piece of paper, a calculator, and let's get started. So part one, we're looking at this square board and it says a square on the board is chosen at random. Find each probability as a fraction in simplest form. And I'm just going to go ahead and let you know that on your basic skills quiz and on your test, most often you are going to give probability as a fraction in simplest form. And don't forget that simplest form means that you have to reduce your fraction. So for example, if you get the fraction 2/4, you need to reduce that to 1/2, okay? Now, let's go ahead and get started. So we've got a square board, and it's numbered 1 through 16. So we're going to find the probability of selecting an even number, right? So that means 2, 4, 6, 8, 10, 12, 14, and 16. Well, I just circled 8 numbers, okay? So 8 is my numerator, and then there were 16 total squares. So 8/16, does that fraction reduce? Well, those are both even numbers, so I know that 2 goes into both of them. But when I look a little closer, I know that 4 goes into both of them, right? Okay. I also, when I look a little closer, I know that 8 goes into 16. So I know that 8 goes into both of these numbers. So 8 goes into 8, or 8 divided by 8 is 1, and 16 divided by 8 is 2. So this fraction reduces to 1/2. Now let's look at the probability of selecting a number that's shaded. So how many numbers are shaded? Well, 1, 2, 3, 4, 5, 6, 7. So 7 of them are shaded. So 7 is my numerator, and there are 16 total squares. So 7/16, does that fraction reduce? And that answer is no, that fraction does not reduce. So we're going to leave it just as is. Okay, now probability of choosing a square that is greater than 10. Now greater than 10 means that it's bigger than 10, but 10 is not included. So I'm looking at 11, 12, 13, 14, 15, and 16. So that is 6 squares. So we have 6 out of 16 total outcomes. Does that reduce? Yes, it does. Those are both even numbers, so I know that 2 goes into both. 2 goes into 6 3 times, and 2 goes into 16 8 times. I cannot reduce 3 eighths any further, so that is my answer. Okay, now number 4, the probability of it being odd or shaded. So odd or shaded. So we're looking at our odd numbers. So there's 1, 3, 5, 7, 9, 11, sorry. 1, 3, 5, 7, 9, 11, 13, and 15. So that's 8 numbers that are odd. Now, or shaded means that I'm going to include these other numbers that are shaded. So 8, 9, 10, 11, right? So there's 11 out of 16 that are odd or shaded. Can I reduce that? Nope, I cannot reduce that. So we're going to leave it as is. Now it's really important on one like that we don't count something twice, because there are odd numbers that are shaded. I don't want to count that twice, okay? Now, probability of it being a multiple of 2 and no less than 5. So no less than 5 means that we're talking about bigger than 5, right? So 5 is like the very minimum that it could be. Now a multiple of 2. So we're talking about counting by 2s. So 2, 2, 4, 6, 8, 10, 12, 14, and 16. But it being no less than 5. That means I have to eliminate 2 and 4. So that leaves me with 1, 2, 3, 4, 5, 6. 6 out of 16. Well, does that reduce? Yes, it does. 2 goes into both of those. 2 goes into 6 3 times, and 2 goes into 16 8 times. So 3 eighths is my answer. Okay, That's the end of that little first section. Let's move on to our second section. So we have a bag of M&M's candies contains 8 red, 5 orange, 6 yellow, 10 green, 9 blue, and 7 brown candies. If an M&M is chosen at random, find each probability as a fraction in simplest form. So the probability of choosing an orange. Well, first of all, I need to know how many total outcomes there are. And the way I find my total outcomes is I add all my numbers together. So 8 plus 5 plus 6 plus 10 plus 9 plus 7. So when I put that into my calculator, I get 45. There are 45 total outcomes. That means that 45 will be my denominator, okay? So the probability of choosing orange, well, it tells me right here that there are 5 orange. So 5 is my numerator, so 5 over 45. Does that reduce? Well, 5 goes into both of those. 5 divided by 5 is 1, and 45 divided by 5 is 9. So 1/9 is my answer. Okay, now red or brown. Well, there are 8 red and there are 7 brown. So 8 plus 7 is 15. So 15 over 45. Does that reduce? Well, I know 5 goes into both of those. So if I divide by 5, I get 3 over 9, which I can see keeps on reducing. 3 goes into both of these numbers. 3 divided by 3 is 1, and 9 divided by 3 is 3, so 1/3. Okay, probability of being not green. Well, there are 10 green candies, right? So I know that there are 45 total and 10 are green. So 45 minus 10 is 35, so we have 35 over 45. So does that reduce? Well, 5 goes into both of those. 35 divided by 5 is 7, and 45 divided by 5 is 9. So 7 over 9, and I can't reduce that any further. Okay, and then lastly, probability of blue and red. Well, here's the thing. If I'm drawing one M&M out of my bag, how can I possibly pick one that's both blue and red? That doesn't happen. So I cannot pick one M&M that is both colors, so the probability is 0. Okay, if it had said or instead of and, it would be a different story, but that and makes that impossible. So the probability is 0. Okay, let's move on to part 3. A card from the set is chosen at random. Give each probability as a fraction in simplest form. So the probability of choosing a card with a striped background, probability of stripes. My striped backgrounds, they're 1, 2, 3, 4, and there are 12 total cards. So 4 of them have a striped background and there are 12 total. So 4 over 12 is my probability, but I can reduce that fraction. So I know that 4 goes into both of those. 4 divided by 4 is 1, and 12 divided by 4 is 3. So 1/3 is my answer. Now 11, the probability of it being a card that is less than 9. That means that 9 is not included, so it's lower than 9. So we're talking about 1 through 8. So 1, 2, 3, 4, 5, 6, 7, and 8. That's 8 out of how many? Well, 12. Does that reduce? I know 4 goes into both of those. So 8 divided by 4 is 2, and 12 divided by 4 is 3. So 2/3 is my answer. Number 12, probability of polka dots and odd. So polka dots and odd. So our polka dots are 2, that one doesn't count. 7, that one does. And 10, that one doesn't count. So the only one that's polka dot and odd is this one right here. So there's 1 out of 12 total. So 1 out of 12 does not reduce. That is my probability. Number 13, probability of it being black or at least 5. So black or at least 5. So all of my black cards count. So 1, 2, 3, 4, 5. But at least 5 means 5 and bigger. So 6, 7, 8, 9, 10. So I'm counting 10 out of 12. So 10 out of 12, does that reduce? Yeah, 2 goes into both of those. 10 divided by 2 is 5, and 12 divided by 2 is 6. So 5 over 6 is my probability. Okay, moving on to number 14. If the spinner below is spun once, which event is least likely to happen? Okay, so I've got to find the probability for A, B, C, and D. And my answer will be the one that is the smallest. So the spinner lands on a number that is at least 9. That means 9 and bigger. So we've got 1, 2, 3, 4, 5, 6, 7, 8, right? So that's 8 out of 16 sections, which is 1/2. And sometimes when I'm comparing probabilities, I like to compare the decimal or the percent. So I know that 1/2, if I put 1 divided by 2 into my calculator, I get 0.5. It might just help to know that and to write that down. Okay, now let's look at B. The spinner lands on a multiple of 3. Well, multiples of 3 are like counting by 3. So we're talking about 3, 6, 9, 12, and 15. Multiples of 3 continue going on, but I don't need to continue listing them because my spinner stops at 16. So that is 1, 2, 3, 4, 5 numbers. Well, 5 out of 16. That fraction doesn't reduce, but if I put 5 divided by 16 into my calculator, I get 0.3125. Okay, so I know now that 0.3125 is smaller than 0.5, so my answer is not going to be A. Okay, so let's look at C. The spinner lands on a shaded number. Well, how many are shaded? 1, 2, 3, 4, 5, 6, 7. 7 out of how many total? Well, 7 out of 16 total. That fraction does not reduce, but I can turn that into a decimal. 7 divided by 16 is 0.4375. So when I compare these two decimals, 0.4375 and 0.3125, this one right here is bigger. So I know that my answer is not going to be C because it's more likely to happen that it lands on a shaded number. So let's look at D. The spinner lands on a prime number. Okay, well, our prime numbers here. Remember, prime numbers are bigger than 1. So 2 is a prime number, 3 is a prime number. 4 is not because 2 times 2 makes 4, so 4 is not prime. 5 is a prime number. 6 is not because 2 times 3 makes 6. 7 is a prime number. 8 is not a prime number. 2 times 4 makes 8. 9 is not a prime number. 3 times 3 makes 9. 10, not a prime number because 2 times 5 makes 10. 11 is a prime number. 12 is not a prime number because 2 times 6 makes 12. Also, 3 times 4 makes 12. 13 is a prime number. 14 is not a prime number. 2 times 7 makes 14. 15 is not a prime number. 3 times 5 makes 15. 16 is not a prime number because 2 times 8 makes 16. Also, 4 times 4 makes 16. So my only prime numbers here are 2, 3, 5, 7, 11, and 13. That's 6. 6 out of 16. So 6 out of 16 does reduce to 3/8, and I'm going to go ahead and convert that to a decimal. So if I put that into my calculator, 3 divided by 8 or 6 divided by 16, I get 0.375. Okay, so what is smaller? Remember, we already eliminated C, so I'm comparing this decimal here to this decimal here. And I actually have to compare the hundredth spot. So 7 to 1. Which one is smaller? Well, 1 is smaller than 7. So this probability is smaller than this probability. And I also know that if I compare the original fractions. So sometimes if you just don't change your fraction to simplest form, you have the same denominator every time, 8/16, 5/16, 7/16, and 6/16. Which one is smaller? Well, 5/16. So that means that B is least likely to happen. So B is our answer. That is the end of this mini lesson. I hope it helps with simple probability.